our last class, we have discussed thermodynamic equilibrium. That means the thermodynamic equilibrium state of a system. In this context, we have discussed the mechanical equilibrium and thermal equilibrium. And today we'll discuss chemical equilibrium. The chemical equilibrium of a system. So when you can write chemical equilibrium. Chemical equilibrium. Then write when the chemical composition of a system, when the chemical composition of the system remains uniform throughout the system, throughout the system, and does not change with time. Then we say the system is in chemical equilibrium. For this chemical composition is uniform. That means the chemical composition is uniform. Another situation, what is non-equilibrium? Non-equilibrium system. Non-equilibrium system. Non-equilibrium system. Non-equilibrium system. A system is said to be non-equilibrium state, a non-equilibrium state if the state variable of the system have different properties. In the different parts of the system. So that is called, that means non-equilibrium case. Next we'll go through the thermodynamic process. What is thermodynamic process? When the system is, you consider a system at a particular condition of state variables, then this is this is called the state of the system. When the state variables changes, then it reaches another state. So from this state point, this is the state point, and this is another state point 1, and this is state point 2. So to bring this system from statement 1 to statement 2, a process is required. That means the ways in which the parameters, thermodynamic parameters or state variables will be changed. The ways in which you can reach at this state in this path, also can reach this in this path, or in this path, any other path. Suppose this is your take a pressure and this is volume. So this is the process. This process can be achieved in various manners. Accordingly, the thermal process is classified as your isothermal process, when this is a process in which temperature is kept constant, throughout the process. Similarly, another system is called adiabatic system. So adiabatic process. In this process, the net heat transfer, there is no heat exchange in this process. There is no heat exchange between this system and the surroundings. Q is constant. Here Q is your constant. You take small q, Q is constant. Or can write, there is no change in heat. So dq is equal to 0. What is dq? dq means you can write change in heat limit delta q tends to 0 is written as dq. Very, very, very small. The net change in the heat is 0. Next process is your isobaric process. This is the type of process in which the pressure variable is kept constant. This is a process in which pressure is kept constant. Then Next type of process is your isochoric process. Isochoric process. Isochoric process. This is a type of process in which your volume remains constant. Throughout the process, the volume remains V because constant. V constant. Similarly, your cyclic process, another procedure, cyclic process. This is the process. Suppose this is a state point 1, here comes to state point 2, then again a series of changes, it comes to this same 1. Suppose this is these points. So this again return to the initial state. So this is called a cyclic process. This is the process in which the system regains its initial state. The another thing is our reversible process. 6. This is infinitesimally small process in which the process takes place infinitesimally slow with time, and it forwards and then backward, then forward, state becomes forward, becomes backward, like this. So that means system is reverse. This is called a reversible process. An ideal system. This is a ideal condition. Another thing is irreversible process. In a reversible process, the process flex instantly from one state to the other. This moves from one state to the other instantly, and the initial state cannot be regained, can never come back to the initial state. So that is called irreversible process. So today this much, and in that class we'll discuss between heat and work, regarding heat and work. Thank you.